Hi, good afternoon and good morning to all. We're just going to be waiting for about 5 minutes just until a bit more of the crowd has come in. So I think that should be 4:05 GMT plus 8 or 9 a.m., 9:05 a.m. CST, your time. So just until we have a little bit more of the crowd trickling in, please be patient. Thank you all for joining us today for this session. We're going to be waiting a few minutes just for everybody to come in. Hi, hello to all just coming in. We're just waiting a few minutes for the rest of the crowd to trickle in, and then we should be starting shortly. Hi, yeah, good morning and good afternoon to those who just came in. We're just waiting a few minutes for everybody to get in on time, and then we should be starting shortly. In the meantime, please make a cup of coffee, some tea, sit down, get ready for a session on the DRS. Let's see. Just give it about a minute to go, and then we should be starting shortly. Thank you for your patience. Yeah, I think we've waited long enough. So with that, let me once again greet good morning and good afternoon to all of you guys who are joining us today. For those of you guys who have actually joined us 2 months ago for the Nitico webinar, welcome back. For those who are new here, hello, nice to meet you all. Today, we're going to be dedicating the entire session to talking about the DRS, which is HPMT's premier drill, and alongside with the new addition, which we're adding to our DRS family, the W12A times D. Before we get into anywhere, let me just quickly run over the agenda. Fish, please. Yeah, so quickly, we anticipate this session to go on for about an hour, starting off quickly with the introduction to the DRS. This is for those of you who might be unfamiliar, and for those of you who are, it's just a quick refresher course as we go into it. Then we will have our technical engineer spend some time here in terms of talking about what are the key features and benefits that makes the DRS tick, followed by benchmarking for DRS in terms of the tool tests, where we'll be showcasing the tool test in 3 different environments. The first being DRS for the multi-material, for those of you who are looking for specific ISO grades. DRS against competitors, for those of you guys who are looking for tool test to pair against an existing product that you may be looking to get into. And finally, the DRS on the conventional and aggressive cutting parameters, for those of you who are looking for an edge in whether in providing a more aggressive cutting parameter or a better result in your machining. And of course, we have a dedicated session at the end, which is the Q&A session. So if you guys have any questions between now and then, rest assured that we'll save some time in the slot to make sure there are enough time for people to get their questions answered. And with that, let me just quickly introduce myself and my co-partner will be joining us today for the DRS session. First, we have me, Adrian, who is going to be coming from HPMT's marketing department side. And together with myself, we have Fish, who is our technical engineer from our R&D team. She will be the one taking us through all of the relevant technical document material, the tool test, as well as any more than layman questions that you guys might have in the questions and comments. She will help answer. Aside that, sitting on the side, we have Sanka, who is our product management manager, and he will be also assisting us on the Q&A questions as well. At any point of time, now is actually a good time to introduce to you guys the Q&A session for the Q&A icon for those of you guys who are unfamiliar. If you move down on your Zoom page, you should be able to see a Q&A where you can input your questions in manually. Rest assured, if you're unfamiliar with the system, you can just type it in chat as well. That should be fine. With that, Fish, yeah, please take it away.
Okay, thanks, Adrian, for the introduction. So, welcome and good morning to fellow audience coming to the Europe side, and also good afternoon to fellow audience coming from Asian side. So today we will talk about the DRS and its new edition product, which is the W12. So before we get into more detailed information regarding to like the feature benefits and so on, I will just guide you through for like roughly what we have under this DRS series. So just so you can see inside this slide, right? Our DRS do come with a non-oil fit design. And for this non-oil fit design, we have 2 different variants in which for W08, we have a 3D cutting length, while for the W09, it comes with a 5D length. On the other hand, we also have another design for this DRS with oil hole. So for this oil hole design, we have EDP of W10. So this W10 is come with 3D length with oil fit. The next one is our W11 that you some of you might already be familiar with it. So this W11 is come with a 5D length of design. And in addition, because we keep on receiving the customers' request to help them to like customize our DRS and make it have a longer sizes. So here we today would like to let you know for whoever are looking for that sizes, we did make another new addition for this 8D design with the code W12. So all of these variants, they are all come with a diameter range starting from 3 up to 20. So before we move on to the next feature and then the next slide, may I know how familiar are you with our DRS? We will have a poll questions for you guys to answer on it. So you feel free to put your answer. You are very familiar, or you might be pretty new to it. Maybe you used to hear us talk about the DRS in the market also. So far, I can see that lots of the attendees here are quite familiar with our DRS, and yeah. just for those new attendees or maybe new users, right? Actually, our DRS has been developed for more than a decade. That's why I can see lots of those very familiar faces over here.
Yeah, I think it's a healthy mix of people who are familiar with our products and those who aren't. Yeah, so we are just using this question as an opportunity to inquire, as well as to give you guys an opportunity to first be used to this polling question, because what's going to be happening is they're going to be throughout the entire session. We're going to take opportunity to gauge the room and see what is the crowd's opinion as to I don't know, anything from cutting parameters to specs to even like appropriate material. So yeah, there should be some interesting things coming along. Thank you guys for participating. And with that, let me just quickly stop sharing this, and then yeah, please continue, Krish.
All right, so move on to this next slide. We would like to let you know why DRS, because you hear it all the while. But for those who might not very familiar with it, I will just quickly go through. So for DRS, right, it is actually a cutting tool, a drill that are very suitable to cut for these 5 different aerosol material. They are P, N, K, N, and S. And maybe some of you are also not very familiar with how what are those code referring to. So just for your information, all those code, right, is actually referring to the metal with hardness tends to be the softer side, which is the aluminum, and up to the metal with more harder side, in which the super alloys such as the titanium alloys and so on. So we designed this DRS because we are targeting for the below industry such as the general engineering that you always hear, mold and die, the very big market for today's technology, these eras, the automotive and energy industries. So what are the linkage in between the material versatility and the industry that we are targeting? Basically, their relationship is because for certain key industry, right? Most of the time when they are trying to produce out their product, they tend to use specific kind of materials only. For like example, when we are talking about the automotive, most of the time they will just use stainless steel or aluminum to produce their vehicle components or parts. While when it comes to the energy sector, and then they will tend to use those more harder material that can withstand those very high heat, have a very strong heat resistance, very tough and so on, such as those super alloys. Yeah, that's why to focus on all those targeted industry, to better focus on them to produce cutting tools that can give a very good performance on the parts. So we design this DRS. And then what are the features that make our DRS to be having that kind of capabilities? Just so you know, our DRS actually do come with plenty features, but the 4 key here are wide chip pockets, straight edge profile, wide K value, corner edge chamfer. Let's move on to look more in detail for how these kind of key features work. All right, so here is the first key main feature we have. This is the wide, which is the wide chip pocket. When we talk about the chip pocket, maybe some of you know where it is. Some of you might not very sure. So you can refer to the diagram in this left-hand side. The region highlighted in purple. It is where the chip pocket locate when we cut our cutting tools into half. All right. So with this wider kind of like a chip pocket sizes, right, it will definitely help to enhance and give a better chip evacuations. Also, because the space there is wider. So when you are trying to flush those coolant through, and then it allows more coolant to pass. Next on, we have the second key main feature, in which for our DRS, we make the flank side to have a straight edge profile. So this straight edge profile is where we highlight in purple for your reference. With this straight edge profile, things that it can help is to, when it attempt the cutting process, it will have to make a shorter cheats. Also, it will have to reinforce the cutting edge, so it won't be that easy to cheat. The fourth key main feature for our this is the third one. So the third key main feature is this white K value. So where is it? You can actually look on the circle. Inside there, right? Just now it prompt out the highlighted purple region. So this is actually where the K value locates. Just so you know, this K value is actually the measurement value we use to measure the thickness of this part. And this region, for better illustration, it is actually where located at the point of the drill. So like, when we attempt to do the drilling process, this is the first part we'll contact with the material. So when we make it slightly wider, it will suitable to work with higher feed rate without to risk the short to life. This is because when it becomes slightly wider, it has the strength to overcome the thrust generated during the cutting process. Also, it will generate lower cutting resistance. At the end, it will effectively help improving the chip disposal. Here we have the last key main feature here, which is this corner edge chamfer. So, Adrian, did you know what is this corner edge chamfer?
I'm assuming you're referring to the lightly create dimensional cut on the top side, right?
Yes. So this area, right, is what we call it a corner edge chamfer, but it also has another name that might be more familiar to you guys, which some of the people in this cutting tool industry, they will call this as a GG point. And usually this GG point is what people will design to clean out the exit parts when we attempt to do the straight hole cutting process. The straight hole drilling process, especially when you are working with the cast iron. Cast iron is one of the very famous material that always faced with the exit burr issue. So with the existence of this corner edge feature, when it attempts the true hole cut, it will clean out the area at the exit part and provide a better surface finishing. So here are the 4 key main features that we designed to help boost up the performance. Here we also have another poll questions.
Just quick to interrupt. I wanted to take the opportunity to ask as well. In regards to the industry having seen all of these features and benefits, is there anything here that you feel might be more important of a feature and benefit to, say, like general engineering or more and die? Like what is your opinion on what is the exciting F&B here, having discussed so far?
I can see a lot of the people are suggesting the general engineering is a good choice.
Yeah, it's pretty much gonna be a winner here on the general engineering part. Actually, I see a lot of people reviewing general engineering after having seen all the features and benefits, which is very interesting to learn. Yeah, that's good insight. Thank you guys for sharing. With that, I think we can move on to the next section, which is going to be on the tool tests, as I understand it, correct, Fish?
But before that, I actually have one question.
Yeah.
Actually, I wanted to know more about my customer because sometimes we have questions when designing the tool. So while we are designing the tools, right, we also wondering actually what is the most important criteria when you are trying to sell the tool?
Important criteria.
Mm-hmm.
Oh, you mean based on the next polling question? Ah, yes, I see what you mean.
Yeah, this is our top 2 questions.
Let me see if I can pull it up. Sorry. Give me a second. Yes. So what is the most important criteria to selling drill? Oh, that is an interesting question.
Yeah, because sometimes we will have the struggle. Like, I think that this is the best the best combination for my customer. But in terms of like the real life situations, I also need to hear their opinions.
Well, I think for me, one of the most important thing we would generally consider is definitely durability. But it'll be interesting to know what everybody here thinks. You can see, please note that you guys can pick multiple answers. So in this case, if you feel there's more than one that you consider important, feel free to include it. And yeah. So
Wow.
yeah, I think that should be everybody.
The price is leading.
Yeah, let me just quickly share the results so everybody can take a look. So we can see a lot of people in the room here really care about durability and the price, much more so than whole quality, material versatility, and machine condition flexibility. That is interesting to learn. Yeah, but I would say it's not surprising, right, Fish? I guess at the end of the day, price and durability is definitely important.
Yeah.
Yeah. So yeah, thank you guys for sharing. We'll continue on with the tool test now.
Okay. So for the next session will be the part that you guys will be very interested on it, in which we would like to showcasing our tool test reports. So under these tool test report showcasing sessions, right, we actually will show you 3 internal tool test report that we have been conduct in our internal machining center. So the first tool test will be our cutting tools performance when working with these 5 different ISO material. And for the second tool test, it will be to benchmarking our cutting tools performance when compared with the competitors. And then the last internal tool test that we would like to showcasing is about our W12, because it is actually our product only for today. So it is quite new. So some of you might pretty strong with it. So we also would like you to know how is it performed. So let's have a kickstart. So for the first tool tests that we are now going to show to you is the performance of our cutting tools when dealing with these 5 different materials. There's also one thing that I would like to let you guys know. At the end of the sessions, right, will share with you our handouts that contains our tool test report and the videos as well. So here, right, because it is actually quite a clear cut for every single material test for your reference. So instead of like spending lots of your time in like seeing all those like drilling process, the repeating one. So rather than doing that, I will try to skim in faster. Instead, I will just show you the result, right? So let's move on to check what happens to our cutting tools when dealing with the first material P. So this is the video. I will fast forward. So this is the result for our cutting tools when it cut on this carbon steel. Like you can see in terms of the surface finishing, we are actually providing a good surface shining, while in terms of the chips, right, it doesn't matter under conventional type of cutting parameter or under more aggressive cutting parameters, both are providing the same consistently short and curved chips. So this look good. What about the next performance? Here we have the second two test result when we cut on this stainless steel. So in terms of the surface finishing, the surface still looking good, while in terms of the chips formation, it is still having a short chips. Let's move on to the third material, which is the grey cast iron. In terms of the surface, like I said just now, we did have when we are dealing with the surface and the drilling with these cast iron, the pain points, the most headache issue that we always face with is the burr issue. But if you look at here, right, actually the entering and the exit is actually still pretty clear, while the chip form is still relatively short. Next on is the result when we are drilled on this aluminum. So in terms of the chips formations, it is still relatively short and curved. So the next one will be our last material, which is the titanium. All right, so here we have the surface and the chips formation for your reference as well. In terms of the surface finishing, our cutting tool still possible to provide an excellent surface finishing, while keep to have a short and curved chips. So in summary, right, our cutting tool, so here I would like to let you know our cutting tool that used to test on this test is our W11 with a 5D length. So after it go through all these kind of materials, right, I think that we can conclude it's doesn't matter what material it is, we still can perform to produce good surface and good chips. Knowing that our cutting tools has no issue to deal with different kind of these different ISO material. Now, what about our performance? Because you might wonder how our performance if compared with the other competitors, right? Because you would like to know where are we positioned and ranked. So here we have the second tool test, which is to benchmarking the competitors with our cutting tools. Okay, this is the slide showing the setup that we are using for this test. Tool that we use is our W11 diameter 8 drill. So things that we want to do is on this NAK80 with a hardness of 40 HRC, we would like to drill 140 holes. Okay, and then the competitor that we use for benchmarking got 7. So why 7 of these? Because they are actually the pretty famous brand that if I say the name, you will know instantly. So knowing that they are pretty famous, we use them to benchmark our performance. And all of these cutting tools, right, will later use the same cutting parameter to drill on these NAK80s. And before we move on to the next session to look on how the tool look alike and so on, we also have another questions to fellow audience. which brand tool you benchmark for drilling usually? Wow, I can see a lot of you love to use Guring, Mitsubishi, Water.
Yeah, I think it's good here that we are speaking the same page in terms of comparing apples with apples. I think from there, yeah, I'm actually interested to know what are the additional, well, what are the competitors' performance against DRS. So yeah, would you want to quickly move on to the next slide?
Yeah. So after understanding what you usually use for the benchmarking, we will take note in the future when designing our products. Okay. So let's quickly move on to the next part. I would like you to know, actually, this is the tools picture before we perform the machining process. So like you can see, every single tool, right, they have they have their unique features come with it. So what happens when we use all these tools and drill on the NAK80? So here we have a short video showing the process. All right, the video ends. Let's check on the tools picture after they have been done doing the machining process. So like you can see here, we have two tools. Unfortunately, they cannot make it to the end, but our DRS still can make it to the end and are giving an average wear for about 0.012 mm. In which, if we comparing this with the others, right, it is actually ranked the second in terms of the tool wear. So let's move on to check the other criterion we use to compare in terms of the performance. So here are the chips formation for each cutting tools. Like you see just now, right, the competitor Y and I1 actually broken halfway. So we can actually see that this is maybe because their tool has been start to chips and wear in the middle. Like you can also observe because of that, the chip formed by them is tangled, inconsistent, and long. While for the other cutting tools, yes.
Yeah, I just wanted to quickly ask Fish, especially coming from a layman's side who might not understand the technical speech, right? How do you establish what is considered good chips and what is considered bad chips here? Actually, is there any way you can explain?
Yeah, actually, in order to understand whether the chip has been formed, is a good chip in general. So you can see whether the starting chip that they form whenever they start drilling, right? Is it short and consistent, having a consistent peripheral sizes? And when the drill has been like drilled up to the middle or to the ending part, and is it like forming a relatively short and curved chips, and whether that side is consistent. So this is also something that you can observe from all those chips formations, like for DRS, right? If you observe the starting chip, it is actually pretty short if you compare with the others. So this is actually a good sign to justify whether your cutting tools is doing good. Next on, we also taking the surface finishing into, oh yeah. Okay, so the next one is we also like taking all those things into the consideration and summarize it for your better reference. So you can see from here, right? We have a bar chart showing the two wear after done drill for 140 holes. Like you can see here, our DRS is actually ranked the second with a relatively low two wear. Well, in terms of the machining quietness, so think that we did observe, right, during the entire machining process, our cutting tools is actually not providing very loud noises. Instead, the machining sound is still just medium and is in the acceptable range. Okay, so here is the another criterion that we take into consideration to check the performance, which is the surface finishing. Like you can see from here, right? This is all the cutting surface that we have been like take the workpiece and cut to half to see what is the inner side shows. So in terms of the tool wear, we are using a RF tester to measure the surface roughness. So DRS has a surface roughness of around 1.059 micrometers. If we are like comparing this value to the others, right, our surface roughness is actually still ranked the second. And for better overview, we take all these three different criterions, which is the machining quietness, the durability, and the surface roughness, and we put it inside this graph and plot their performance in terms of the ranking, so you can have a better overview. Like you can see, our DRS is represented by the red lines, in which in terms of the machining quietness, it ranked the middle, while in terms of the durabilities, our DRS ranked the second and is consistently ranked the second for the surface roughness as well. So we are consistently giving a good performance. In conclusion, with referring to this overall performance ranking, we can see that our DRS is capable to performing good results and compete with all those very famous brands in the global arena. So before we move on to the next two tests, we also would like to let you know, seeing that we would like to launch our W12, right? We also receiving our customers' feedback that they actually hope to see our cutting tools W12 performance based on conventional and the aggressive cutting parameters. So we conduct these two tests, and here are our settings. Like you can see from here, our main objective to conduct these two tests is to first study whether the tool can run under both conventional and aggressive cutting parameters. Secondly, we would also like to understand our cutting tool's performance when compared with the competitors. Thirdly, to test whether our cutting tools can run under flexible cutting parameters. So with this kind of objective, we come out these two tests to drill on the sustainable steel 316L. And then two that we use for benchmarking is competitor G and S. This is considering we have customers from the worldwide. So we choose one cutting tools that are providing drill and is pretty dominant in the Europe region. And another competitor that are pretty dominant in these Asia regions. While in terms of the cutting parameter setup, right? Because we also would like to know whether we can run under flexible cutting parameter. So we set up 4 different set of cutting parameter for this task. Here is the range for where all those cutting parameters locate. So the balloon with the numbers 1, 2, 3, and 4 is referring to our cutting parameter used in this experiment. Like what I said, we set up 4 different cutting parameters, right? So what are the justification we use to set up all those values? First of all, understanding their customer tends to use conventional cutting parameters. They are also customer tends to use more aggressive cutting parameters. So knowing that the competitor G is actually pretty famous that are always suggesting the aggressive cutting parameters. So we set up our cutting parameter to have certain of it will be on par with it. Like you can see here, right? And also with referring to the customers like wishes, some of them might need to maybe they have like a lower end kind of machines, so they might have to move slower. So and also they might be working in this automotive industry that might sometimes they always like using a more conventional side of like cutting tools. So we pick a competitor S that are pretty dominant in that area and plot out their cutting parameter. And from there, right, we set up our first cutting parameter to be on par with competitor S, and then increase it a little bit so it can on par with the other competitors. And knowing that competitor G is on the more aggressive side, so we set up our third set of cutting parameter on par with it. And to better understanding where is our limitation, so we set up the fourth setting, the fourth set of cutting parameter to be having a cutting speed much higher than the competitor G's. So let's move on to have a look. How do we set up these tasks?
Wait, before we get into that, Fish, I have a question. Sorry,
Yes.
Can you go back to the previous slide?
All right.
Yes. So as I understand it, basically starting from 1 to 4, 4 is the most aggressive cutting parameters we're looking at that exceeds even the general market. Is that correct?
Yes.
And 1 is basically the conventional one that starts from competitor S onwards, which is a big competitor in automotive, you were saying?
Yes.
Okay. Okay, I understand now. Yep. But actually, I think with that, there's actually another question, a poll question here as well, isn't there? Let me, yes, sorry, I'm getting a, yes. So what I'm understanding here from behind the scenes is we also have a question here from R&D wanting to find out whether if this range of cutting parameters on the graph, which is what we're using the DRS to benchmark, is it something that you guys are comfortable or the conversation is the same as the range that you would share, you would speak to with your customers? Are we on point with the range? Are we too broad? Are we too high? Are we too low? Yeah, please give us some feedback on this, as we're interested to know what kind of conversations you guys would have with your customer on the cutting parameters range usually, especially with the DRS that we're showcasing now. And just give it a few seconds here for everybody to fill in their answers. So I'm just gonna quickly share. Yes, so I can see the majority of the crowd here seems to be more familiar with the cutting parameters range for number 2, which I think is more in line with the HPMT DRS and this competitor M. Okay, that's interesting to know. I hope the results later is up to everybody's expectation. Yeah, sorry for the interruption, Fish. Please continue.
All right. Okay, so let's move on to check on the setup that we use for this experiment. Okay, so this is actually the CAD diagram showing how we set up, how we apply the cutting parameter in the 4 different regions on this stainless steel workpiece. So like you can see, we divide the entire workpiece into 4 different regions, which is A, B, C, and D. So we are targeting to drill a total number of 651 holes. And from here, right, we divide these workpiece into 4 sections. For side A, we will put our first set of cutting parameter over there and drill for 155 holes. When it is finished, we will stop, check on the tool condition, then continue to the second set, which the second set of cutting parameter that have a higher cutting speed. And once it also done, drill the another 155 holes. We will continue to the third section with another higher cutting parameters. Something happens to the fourth set. So at the end, we will achieve a total of 651 holes. So let's move on to check what will be happened during the machining process. So here we have a video for your reference to see how we do it. Okay, so our machining video has been ended. Let's look onto the results. So here we did collected the tool condition after done every single machining on the 4 set of the different cutting parameters. Like you can see from here, right? When we first done drill on the 155 holes, all of the tools seems good. But when it comes to the second set of cutting parameter, after 310 holes has been done drill, unfortunately, we observe that competitor S starts to have a very significant chip and wear condition at the point part. When we move on to the third set of cutting parameter, competitor S broken, while our HPMT's double shaft and the competitor G's cutting tool still can continue. And when we have been done drill on these 651 holes, right, both two has been done and continue to the end. Let's have a closer look for how was the wear pattern formed over here. Like what you can see, because the competitor S cutting tool has been broken halfway, so we didn't collect its two wear patterns. Instead, we will now temporarily just compare in between our double shaft and competitor G. So here, things that we can observe from the appearance here is, for competitor G, it have a more significant heat expansion at the point area and also at the cutting edge region, in which you can refer to the slightly darkened region exits at the cutting edge side. While in terms of the tool wear, right, our cutting tools, the DRS 12, the average flank wear is around 0.023 mm, in which it is actually almost half of the competitor G's. While when we are considering including this tipping wear into our consideration, the average wear is around 0.057 for our W12 and 0.059 for the competitor Gs. So so we are more or less are the same. Okay, things that we can conclude from these two tests is, in terms of our cutting tools performance, we can withstand, we can work under different cutting parameter. It doesn't matter you are trying with the conventional one or the aggressive one. Instead, if you look at how the wear pattern form at the end after it done these 651 holes, actually in terms of the tool wear, it is not much. So I believe our cutting tools actually still can go further than this. In conclusion, our cutting tools is still giving a good performance under an 8D design. Next on, we actually did also have some customer, they buy our tool and test it. So here we have two different tool test report received from our customers. We would like to show you as well to understand if using our cutting tools to work on the real life conditions, and then what are our tools performance. So for the first two tests, like you can see over here, this is shared by our customer coming from Japan. They are actually trying to drill an emphasized hole. So initially they are trying to use the competitor M's cutting tool, but they face with the tool life issue in which 2000 hole is actually not enough for them. So they tried with our DRS W10, which is the 3D length design. And from what they shared, our cutting tools are capable to drill up to 3000 holes, and they are pretty satisfied with this result because they say from the tool wear pattern and so on, the tool actually still able to continue further. Next on is the last two test report. And this is the two test report shared by our customer from the aerospace industry. So thing that they are trying to do is actually they wanted to ensure with using our cutting tool, we are able to complete to drill 55 holes within their targeted tolerance range, and also shows a minimized tool wear. So material that they are using over here is actually the TI6 aluminum, all right? So it is super alloys. So this is the cutting parameter setup that they are using. Let's have a check what they are actually trying to do. So this is also the picture shared by them showing what are the kind of hole that they are trying to drill, like the one that you can see pointed by the arrows. So this component is actually a jet engine. And regarding to what they share with us, thing that they conclude is with using our cutting tools, we are capable to complete drill the 55 holes, and the machining load produced along the cutting process is less than 10%. In the meantime, they also observe that the chips are also being able to evacuate properly. The machining size that has been produced is also within the acceptable range. Most importantly, they also suggest that our cutting tools actually still capable to continue the drilling process. Overall, seeing all those internal and external testing reports, I can say that we did test our DRS, and all of those results are showing a good sign in terms of the performance, tool life, and many more. So this is all about the two test results that I can share with you guys over here. So next on, I will pass these sessions to my colleague, Adrian.
Thank you very much, Red. I think that was a lot of insightful tool tests, especially the interesting bit about how our customers are using the DRS for industrial applications. If I could trouble you to just quickly move the slide.
Yes.
So now that we've concluded with the tool test as well, I just want to remind customers that in regards to searching for drilling solutions based on performance, based on material, or based on diameter, we actually have a few others alongside the DRS family, most notably the DR Mini, the DRLX, which is our long drill solution. And just up and coming recently is our Easy Drill, which is our latest cost-effective standard drill. And for those of you who might be looking for something outside of this scope, next slide, please, Vin. We actually have an array of drilling solutions, whether if you have specific needs based on material hardness, based on length, diameter, or even coating. So if you guys have any questions or interests or requests for a specific leaflet, for any of these products here, please note that we'll be including these handouts and sending them off to you at a later time. No worries on that. Hopefully we have you on our newsletter, and if not, you can next slide, please, Fish. And if not, you can actually come onto our website at www.hpmtindustries.com or wait until the end of this session, and then we'll collect it and pass it on to one of our dedicated sales associates. But before that, let me just quickly start off our Q&A session. I can see there's some questions here right now. I think we're 1, 2, 3, 4. There are about 5 questions. So I guess we'll pass them along. Sankar, are you here by any chance? The first question we're actually having here is, how does HPMT new DRS differ from the competitor? I think this one they're referring to the new variants we have, the W12A×C. Do you guys want to take it by any chance?
Yeah, let me answer. Firstly, thanks for all the audience that be very patient until almost 1 year to listen the products launches. Of course, DRS is not totally a new product for HPMT family. In fact, we have a big product portfolio for drills, and DRS is the fast-moving, high-potential product. Both in Europe and Asia, we are selling quite well. That's why we are adding a product extensions. Seems we receive a lot of customers to add request the extensions. Before that, we have 3D and 5D with and without oil hole. So seems the good product needs some extensions. That's why we are introducing the 8D with the oil hole. So we won't see any challenges. So the question here, how is different from the competitors? Of course, DRS is a universal product suitable for multiple material and flexible working conditions, and is very easy to regrind. That means at any working conditions, and also for any materials, you can able to apply these tools. And the best part is definitely drills, everybody need to regrind, and how easy to regrind and get back the equal or lesser than 10-20% of the tool life from the original version. That is a success of the drills products. So hence, we won't see much problem from the DRS family, entire family. Thanks, Adrian.
Yeah, thank you for that, Sankar. Another question we have is, the range is in metric sizes only. I think, yeah, they want to ask whether if it's...
Yeah, we have all the standard products available in the catalog is followed by metric sizes. Of course, there are few or popular inch size we can able to produce as a standard special. That means it's a custom made tools with a reasonable volume. We can able to produce, yes.
I see, thanks for that, Sankar. And there's another question here asking if the DRS is for pilot, can they do pilot holes? Yeah. I see Fish would like to answer this question. Do you?
Fish, you muted.
Fish here, yeah.
Yeah.
So is there a pilot hole on our DRS? No.
Well, there you have it. I think that's a short, concise answer.
Yeah.
Yeah, I can elaborate a little bit more. Our drills is not necessarily need to have a pilot drill. In fact, this tool also can act as a pilot drill. you can continuously drill. If not necessary to apply a separate pilot drill when you're using our DRS.
I see. Okay. Okay, thank you very much. So that's a pilot hill. We still have two more questions here. One is, since this is the new kind of product HPMT is launching, do you foresee any problem with competing in the market? I think they're referring to the A times D. Yeah, Sanka, I can see you're thinking about
this
this.
is not really challengeable applications. In fact, 3D, 5D, 8D, 10, 12 is the common in the market. See, even HPMT also we have up to 30D. So this is the successful product that we extend into 8D. In fact, we have an 8D product with the 4 land burnishings. Is a little bit on the high end product we also have in our portfolio. Adrian?
Yeah, all right. Thanks a lot, Sanka. We just have had 2 questions so far. First is from Mr. Chayan Metacharunan. He's asking, how much is the coolant mixture for each of the materials? I think he's referring to the multi-material tool test. Do you happen to have that information off the cuff? You're muted, by the way.
It means in terms of the coolant mixture for each material, right? Yeah. I'm not sure whether I understand your questions correctly, but if you are meaning whether we have to use like the wet kind of the flooded kind of cooling condition or like a MQL kind of cooling conditions. So just so you know, for the material, all of them, right? It is better and it's suggested to run under wet cooling conditions. While for the other 2 material, one of them will be the P, and also the other one will be the K. It will it actually can run under MQL conditions. And for that kind of information, right, you can actually grab it from our catalog and at the cutting parameter side, at the bottom side, and then we have been listing out like the suitable coolant condition to use with every single material.
Yes, okay. Thank you a lot, Fish, for answering that. Hanan, I hope that answers your question.
Then the last question, we still have one more questions. Okay. Thanks, Mr. Idris, for your questions. Yes, 8D drills or even 3D and 5D and 8D, anything diameter 3 mm and above, no need to go for a picking. You can direct drilling. So picking normally they apply for a small diameter, very, very small diameter. Example, below 1.5, below 1 mm, they will generally apply picking.
Oh, we actually have a just recent question from Mr. Dimitri. He's asking, for the white K value, won't the drill be moved out of the axis of the drilling direction? Yeah. Sanka or Fish?
Yeah, I will answer this question. Thanks for the question, Mr. Dimitri. The white K value is actually protect the chisel edge from chipping. And also the rigidity will provide more centrifugal centering when you apply the drills. So it's one off center. And also it's sharp. With our edge protection chamfer, you can get the very good surface finish with the good centering.
He has a follow-up question as well. How does the W-shell perform on 50 HRC ISO-S material? Yeah, I think we've had the tool test for that, but would you like to give a more comprehensive answer, guys?
Okay, thanks again, Mr. Dimitri. So far, we never tested 50 HRC superalloy materials. The highest we test is inconel, below 40, and also some titanium materials. So this is the application. Is possible to drill? Yes, definitely can possible to drill at certain conditions. You need to apply the low cutting speed and low cutting parameter. Definitely the drill can able to perform. But here we need to like to understand more about your target, whether you need how much the tool height, what's the tool depth. So probably we will touch with you for separate session to understand more about these applications. And it's quite interesting. we would like to test this. Our sales team will come back to you.
Yeah, this one I'll make a note of it and make sure our salespeople know. With that, I can see we've answered all of the questions. Just a quick shout out. Does anybody want to ask any more questions? Just a few seconds to add in. I think that is, that should be it.
Yeah, even if any questions in the future, you can reach out as any times. We are the most happy and welcome to help you on this.
Yep. So thank you for that, Sanka. I think with that, what we can do is just to remind customers that for those of you guys who are looking for more marketing materials for the DRS, just remember you can find them on our website, or you can just quickly click the QR code to download them now. Alternatively, the handouts and all the information for this as well, we will be sending it off in our newsletter for the MailChimp. So hopefully in regards to that, we have answered most of the questions you guys have. Again, any additional questions, please reach out to us or the dedicated sales associate in which you're connected to. And with that, I think we can call the end of the session today. So thank you very much all for coming in today. Thank you, the speakers, Fish and Sanka. Thank you very much.
Thank you all.
Thank you.
Bye.
And
see you in the another session.
Okay, see you.
Bye.
Thank you.